This is pull request 26062 for llama.cpp. It adds model context protocol server support, enabling the Llama server to expose tools from external processes. This is experimental work that brings dynamic tool extension without requiring built-in development. The PR pursues two primary objectives. First, integrate MCP servers so external processes can expose their tools through the existing /tools endpoint. Second, build the full transport layer with child process spawning and JSON RPC messaging. Along the way, it extracts a reusable pipe primitive, adds command line flags for configuration, and extends the toolbase class with polymorphic type identification. Two constraints are respected. The existing tool API stays compatible, and the server maintains non-blocking teardown even when child processes die unexpectedly. Before this change, every tool was hard-coded into the Llama server. If you wanted to add a new capability, you had to modify the server code and rebuild. After this PR, you can configure external MCP servers via command line flags, and those servers expose their tools through the same /tools endpoint. No rebuild required. This opens the door to tool providers from the broader MCP ecosystem, like those already used in Cursor. Let's look at where the changes live. The heart of the work is two new files in tools/server, server-mcp.h and .cpp, which implement the JSON RPC transport and child process management. Server-h gains a new generic pipe template that was extracted from the models module. Server tools gains a small wrapper class and registry integration. Server.cpp orchestrates the MCP manager lifecycle. The common module picks up new command line flags and config fields. All told, 19 files touched, mostly net new code. Here's the transport flow. At startup, the manager spawns each configured MCP server as a child process with standard I/O pipes. A reader thread pumps ND-JSON frames from the child standard out into a bounded queue. When the server needs to list tools, it calls send_RPC, which writes a JSON RPC request to the child standard in, then polls the queue until it finds a frame with a matching message ID. Notifications without IDs are skipped. On shutdown, the manager closes the pipes and joins all threads cleanly. That's how we get reliable request response over stdio. One notable refactor is the new server_pipe template. Previously, server-models had a local pipe_t with basic push and pop. The new version adds close_write and close_read atomics for graceful shutdown, a bounded queue with max_size to prevent unbounded growth, and a read method that supports both blocking and timeout modes. This extracted primitive is now reused by both the models module and the MCP transport, cutting duplication and giving us stronger shutdown guarantees. The toolbase class gains a polymorphic type method. Built-in tools return the string built-in by default. A new server_MCP_tool subclass overrides type to return MCP, and delegates invoke to the MCP manager's call_tool method. This lets the /tools get endpoint report whether each tool is built in or comes from an MCP server, which is useful for clients that care about provenance. After this PR lands, the Llama server is dynamic. Users supply -mcp-servers-config or -mcp-servers-json, and the server spawns those external processes at startup, discovers their tools, and exposes them through the existing /tools endpoint. Tools are named server_tool to avoid collisions. If an MCP server dies, the manager respawns it on the next invocation with a cooldown to prevent thrashing. CORS defaults to localhost when MCP is enabled for security. The /tools response now includes a type field, so clients know whether they're calling a built-in or an MCP tool. Everything tears down cleanly on shutdown. 6 concerns were found. The top right quadrant is empty, meaning no high-impact, high-likelihood issues. The most notable concern is silent empty tool registry when all servers fail to spawn during warm-up. Medium impact, lower likelihood. 2 notification flood scenarios sit in the middle, bounded queue growth and deadline timeout under flood. Polling latency on slow child startup and the non-obvious endpoint enablement logic are in the lower right, more frequent but lower impact. Silent name collision skipping is mid-range on both axes. Let's look at a couple of these in detail. When 2 MCP servers define tools with identical bare names, only the first one makes it into the registry. The setup method builds a scene name set from built-ins first, then iterates servers in discovery order. If a full name like server_tool already exists, the collision is logged as a warning at line 1213, but the duplicate is silently skipped. There's no precedence order documented, and discovery order is stable but undefined to the user. This could surprise someone who expects both tools to be available or expects an error. The warning is good, but silent skipping might warrant stricter validation, or at least clearer documentation. Config parsing at startup can throw in 2 ways. If the JSON file is missing, line 6 throws a runtime error. If the file exists but the JSON is malformed, line 8's parse throws. Both propagate to server.cpp, which catches them and exits with code 1. That's correct. However, individual server warnings, like missing command at line 12, are logged but don't fail the startup. If all servers fail to spawn during warm-up, the server continues with an empty tool registry, which is silent unless you read the logs. The /tools endpoints are enabled as long as configs is non-empty, even if the registry ends up empty. This is technically correct but not obvious, and it could lead to confusion when tools don't appear. This is a substantial feature addition. It brings dynamic tool extension to llama.cpp through MCP servers, with careful attention to process lifecycle, non-blocking teardown, and comprehensive test coverage. Several notes were found, mostly around edge cases like name collisions, silent spawn failures, and notification flood handling. The implementation is thorough, the extraction of the server pipe primitive is a nice refactor, and the test suite covers the key failure modes. The MCP transport code lives in server-mcp.cpp. Tool collision resolution is at server-tools.cpp line 1205, and the warm-up timeout and respawn cooldown are configurable at server-mcp.cpp lines 708 and 825.